Hi class. All right, today I'm going to go over a few graphing techniques for Lab 7, which is where hopefully most of the members of your group performed a treadmill protocol and two different bike protocols, the Astrand and the YMCA, in order to estimate VO2 max. So you can see I have a very long and detailed data sheet here, or a spreadsheet with all of my data. So here are my subjects. We had 3 males and 3 females for a total of 6 subjects. And this is all of their demographic data, as well as the raw data for the multi-stage treadmill protocol, in which I've calculated VO2 using the equation that you can find on table 4.3, pages 88 through 89 in your Hayward and Gibson textbook. I think the page numbers are a bit off on your assignment, so please refer to these page numbers just to avoid frustration. So it'll walk you through the equation and how to appropriately go about finding or estimating VO2 max during your multi-stage treadmill. The Astrand Rhyming, you're going to use the nomogram or the nomogram found on figure 4.8 on page 103 of the textbook. So you can see I've gotten my VO2 data, and keep in mind that that's in liters per minute, and you need to convert that into milliliters per kilogram per minute, because that is what we are comparing. Right? So, and then for the YMCA protocol, you're going to graph it, and that's how you'll estimate VO2 max from the graph. Okay, and again, the VO2 max on that graph will show up in liters per minute, and you need to convert that into milliliters per kilogram per minute. And so one thing that I want to point out with my spreadsheet is that I've done all of my calculations in Excel. Right? So I have a very bad habit of doing my calculations on little Post-its and then losing the little Post-its and having no idea once I go to start graphing things why my data looks the way that it does. And so just a very good habit to get into is performing all of your calculations in Excel. Even if this is a little too lengthy, you want to go ahead and make several columns to do step by step. For instance, this multi-stage treadmill equation there's about 4 to 5 steps to get to VO2 max, so you can certainly outline each individual step. All right, but what I've done is I've created a different sheet, a little cleaner. I've taken the means and standard deviations for both my 3 men and 3 women that participated in our group, and then I've also combined across all subjects, and so I have the mean and standard deviations there as well. So one thing that I didn't do was I didn't copy and just paste the value. I actually did go through, so now I know where exactly I got this value. Right? So if I were just to come in here and either typed or pasted 47.9 milliliters per kilogram per minute, I would have no idea where I actually got that number from. So again, just staying organized. Yes, it is kind of a nightmare to have to go back and forth, but again, in the long run, if something goes wrong, which inevitably it does, you know exactly where your mistake was. Okay, so it'll save you some time in the future, trust me. All right, so the first thing that I wanted to look at, and again, there are several different hypotheses that are circulating out there. You were to come up with 2 of them, but one of the things that I thought would be interesting was to look at the difference between the men and the women, to see if maybe they fared better in one test versus another. So I'm going to start off by graphing the male-female data in all 3 protocols. So I'm going to create a clustered column chart to do that. And so now I have this blank canvas. I'm going to right-click and select data. And the first series I'm going to add here is going to be male. And I'm going to select all 3 values, all mean values for the treadmill, the Astrand, and the YMCA. So just Command select, all 3 are highlighted, and then I'll do the same for female. Okay. All right, so now I have blue is male, Orange is female. And let's go ahead and make this just a little bit bigger. All right, so now, of course, 1, 2, and 3 tell me nothing, so I can fix this a few different ways. All right, I can go in after the fact, add a text box, but I think what I'm going to do is I'm going to go to select data, and on this, doesn't matter which series, on this category X labels, I'm going to type in my X axes variables. Okay, again, I want to be able to see that. All right, so that looks pretty good. I'm going to go ahead, I'm not going to fuss with the y-axis quite yet because I want to get my error bars in. So you should have calculated your standard deviations for the men and the women. So same thing, so I'm going to highlight, when I click on that leftmost male column, all three are highlighted, so similar to what I did with the means. I can select, let's see, go to chart layout, and hopefully you have this error bar drop-down menu. We're going to go to options. We're going to go both directions, so plus and minus. Cap, remember that's just a matter of preference. Select custom, and we're going to specify the values to be our standard deviations. So for males, there's the treadmill, Astrand, and the YMCA. So all three are highlighted. And let's do the same for the female data. Again, chart layout, error bar options, command select, okay, and just keep checking in and make sure this looks like it makes sense. That's a pretty long error bar, but as you can see over here, the standard deviation is plus or minus 17. So again, with the female, there was quite a bit of standard deviation, 15.8. So does that make sense? And then way down here, obviously the YMCA bike test, there was a little less standard deviation than, say, the Astrand. And then, of course, compared to the treadmill. So make sure that your data looks like it makes sense as you proceed. So I do want to clean this up a bit. Now, we could definitely tighten up the graph and bring it, say, up to about 25, or just maybe right under that error bar. But I think I would like to start at 3.5. And the reason is because that is resting VO2. And I like to think of those columns as the size of our tanks. But again, that's just a matter of personal preference. Okay, and so we can definitely clean this up a little bit, this value that's kind of hanging out in no man's land. We can take this up. And again, this is just more of an aesthetics preference, it's not right or wrong. It's just a matter of what personal preference. So we are missing something. We need a label over here. So let's go to chart layout, axis titles. We want a vertical. So this is predicted VO2 max. And don't forget units, milliliters per kilogram per minute. And let's make that, yeah, there we go. All right. Okay, so now I'm just getting fussy. Okay, we're not gonna deal with that. But there you go. All right, so that's about as much as you can do in Excel. Yeah, it's driving me nuts. Okay, there we go. Okay. All right. So now I have my picture, and say I ran stats, and it turned out that there was, my hypothesis was that there was going to be some sort of difference Maybe the females would have fared better than the males, or there would be less variability between females and males, for instance, with the treadmill protocol. But say I found nothing, all right? Then you found nothing. You go ahead and copy this into your Word document. You create a very descriptive statement about what you found underneath the graph, and you call it good. But say my other hypothesis, another thing that I wanted to look at, was I wanted to compare the different methods. Now, if I didn't see any statistically significant difference with men or women, okay, in theory, I could maybe collapse that data or combine the men and the women in one group, and now I've essentially doubled my subject population, right? So there might be a little bit more power. So what I can do, I'm going to move this, move it. I'm just going to call it male and female. Okay. So let's head to my other data. All right. So say I want to compare the three methods, regardless of gender. All right. So we're again going to select clustered column because out of the column charts, that seems to be the closest to the picture we're trying to create. So I'm going to right click. This time, we're going to create a series called treadmill. And Astrand. And YMCA. Oops. Okay. All right, so a little bit clustered together. Okay. Let's go ahead and fix that. So one thing that we can do, first of all, we got to get rid of this one. Okay. We can go up to these quick layouts over here and see these are a little bit more spread out, and it also has a legend, if you can see this, a legend on the bottom. And I think that's actually going to, make what we're trying to do. Okay, of course, get rid of your chart title. You don't need it. Okay, because you're going to write a caption underneath. It's going to tell the reader what they're looking at. So we can go ahead and fix this a little bit and maybe spread it out. Okay, not bad. So you can fuss with this a little bit, but I'm kind of liking the way that that looks. So again, I want to change this to start at 3.5. Again, matter of personal preference. Okay, and let's not mess with this maximal value until we get our error bars situated. So both directions, plus and minus. Naturally, there are shortcuts to this that I will probably show you at a later date. Let's see. And okay, all right, does that make sense? Okay, so it look like about 3.7 standard deviations in each, or 3.7 milliliters per kilogram per minute in each direction. All right, so that reminds me we need to create an axis over here, axis label. right, and we can get rid of this guy out in no man's land. Okay. All right. Oops, sorry. Getting very fussy. Yes, and now you're getting to know way too much about me. All right. There we go. You know what? I might want to change that. My little cap came off. I think I needed to go a little higher. Okay. I don't want to go to 65. There we go. Okay. All right, so you ran stats, and say you didn't find any difference between the two bike protocols, and you didn't necessarily find a difference between the Astrand and this treadmill protocol, but there was a statistically significant difference between the treadmill and the YMCA protocol. Well, how are you going to tell your reader that, aside from having them read your entire paper, your entire result section? Well, we want to have that within our picture. So I think we've done as much as we can in Excel at this point. So what I'm going to do is I'm going to right click. Oops, no I'm not. I'd love to right click and have this be normal. There we go. I'm going to copy this into our lab document. Okay, so let me get rid of this. Jumping a little ahead of myself with the figure or the caption. Okay, so I'm going to right click again and I'm going to choose Paste Special because I want to paste this as a Microsoft Excel chart object. And the reason is because it's going to keep my formatting. Okay, so we can just clean this up. All right. So we want to denote significance between treadmill and YMCA. So we're going to do that via an asterisk very large asterisk, in fact. And a bracket. So I'm going to go to shape and I think this will get the job done. Okay, so we have three different methods on this graph. Now, if we just had two, you could get away with maybe just an asterisk right over the error bar here, and then writing in your caption that the asterisk denotes significance, and the reader will immediately assume that, well, the significant difference is between the two that you're looking at, right? Because there's only two featured. Well, we have three. So I think in this case, just to make sure that your reader doesn't get confused, it's a good idea to use a bracket linking the two. So if I go to wrap text, let's see, I want my bracket in front of. Okay, and then we can move or put the asterisks. And you can certainly work in Excel. You might be able to remove this border, but I think that looks just fine. Okay, you can command arrows to get everything just so. Then you can go back to your caption. You know, write something wonderfully descriptive about what occurred in this within these three protocols. And then you would say that the asterisk denotes, and just in case someone doesn't know what an asterisk is, denotes significance between methods. And then, of course, you always want to put your p-value in parentheses at the end so that the reader knows how significant or insignificant it might be. Right. All right, so I do hope that helps. If you have any questions, please email me, hardinge@unm.edu. And if not, I will see you tomorrow in class.